Why is gravity so hard to isolate for anti-gravity? Imagine a world where gravity is not a constant force pulling us down. What if we could float freely, defying the pull of the Earth? This idea has fascinated scientists and dreamers alike. However, isolating gravity for anti-gravity concepts is a complex challenge. Let's break down why this is the case. First, gravity is different from other forces. It is a universal attraction that affects all matter and energy. Unlike magnetism, which can be shielded or manipulated, gravity cannot be turned off. This is because gravity is not just a force. It is a curvature of spacetime caused by mass and energy. Albert Einstein's theory of general relativity explains this concept, showing that mass bends the fabric of spacetime, creating the effect we know as gravity. One major reason gravity is hard to isolate is its universality and weakness. Gravity pulls on everything with mass or energy, and it is the weakest of the four fundamental forces. This means that creating a localized area free of gravity or reversing gravity is not something we can achieve with current technology or known physics. Another challenge is the absence of known anti-gravity materials or fields. In magnetism, north and south poles create attraction and repulsion. However, gravity has no known opposite. There is no negative mass that could produce repulsive gravity. Scientists have not discovered stable forms of negative mass or energy that could generate anti-gravity effects. Experimental challenges also play a significant role. Gravity is always present and influenced by nearby masses, making it difficult to isolate in experiments. Even in microgravity environments, such as those found on orbiting spacecraft, gravity is not absent. Instead, it is balanced by free-fall conditions. Attempts to create artificial gravity, like using spinning centrifuges, simulate gravity through acceleration rather than canceling it. Moreover, gravity interacts with other forces and matter in complex ways. Some speculative theories suggest exotic matter or energy forms might produce anti-gravity-like effects, but these remain unproven and highly theoretical. From the realm of weird science, many attempts to isolate or negate gravity have led to strange and unexpected findings. For instance, spinning objects or using superconductors have produced peculiar effects that some interpret as hints toward anti-gravity. However, these results have not been reliably replicated or explained within mainstream physics. In practical terms, the closest we get to anti-gravity is creating artificial gravity environments. This is done to counteract weightlessness in space, using rotation to simulate gravitational pull. While this does not isolate gravity, it cleverly uses motion to mimic its effects on the human body. Ultimately, gravity's nature as a universal, always attractive curvature of spacetime makes it incredibly challenging to isolate or reverse. While quirky experiments sometimes hint at strange phenomena, no verified anti-gravity technology exists because gravity cannot be switched off or shielded like other forces. The quest to understand and manipulate gravity continues, leaving us to wonder about the mysteries of the universe.